Good day, everyone. This is the group of Akol, Anggot, Baksal, Baldos, and Baoy to present the assessment of the BENTHIC community structure and composition in Matarinao Bay, Philippines. BENTHIC communities typically support light-dependent species such as corals and algae, which primarily obtain energy from photosynthesis, and animals such as sponges and mollusks, which obtain energy by feeding on other organisms and organic matter. These communities are essential in maintaining the completeness and functionality of a marine ecosystem, and they also provide important ecological services. However, human activities such as coastal degradation, offshore infrastructure, oil and gas development, and pollution have put these benthic ecosystems in peril. The benthic life form and coral reef cover are declining due to a multitude of stressors. This study aims to assess the benthic community of Matarinao Bay and to achieve the following objectives. Number 1 is to determine the composition and percentage cover of the benthic communities in Matarinao Bay. Number 2 is to assess the ecological indices of the benthic population, namely live coral cover index, mortality ratio, and bioerosion ratio. Number 3 is to distinguish underlying relationships between live corals and other categories of the benthic population, specifically with dead corals, algae, and other fauna and abiotic variables. And number 4 is to develop a management plan for coral reef conservation in Matarinao Bay.
For the materials and methods of this study, we first have the study area. The study was conducted at Matarinao Bay, Eastern Samar. A total of 7 sampling sites were surveyed from the inside and outside zones or sectors of 4 marine protected areas, namely Dio Island and Minalongon in General MacArthur, San Miguel in Hernani, and Bulawan in Salcedo. For the data collection, due to health concerns brought by the COVID pandemic, secondary data sourced out from BFAR fish coral and UP Reefs was utilized in the study. A request letter for the said data was first provided prior to the usage of the raw data for the benthic community in Matarinao Bay from April and May 2019. For the analysis of data, the first variable to be assessed is the benthic community composition and percentage cover, where from the raw secondary data of the benthic community in Matarinao Bay, each score was initially tallied according to the respective categories and identification or IDs. Afterwards, the percentage cover of each category and ID per site was calculated through the following formula, which is to divide the score of the category or ID on the transect by the total score of the transect and then multiplied by 100. The next procedure is the assessment of the live coral cover index. In assessing the live coral cover index of the benthic community in Matarinao Bay, the percentage cover of the live hard coral was utilized, which is the standard variable for reporting coral reef health. It was then evaluated using the 5-point category scale by Uchiakao et al., where a score of 1 would indicate a very poor coral condition and a score of 5 would indicate an excellent coral condition of the area. Next is the quantification of the bioerosion and mortality ratio. The bioerosion ratio was calculated by dividing the percentage cover of hard corals with the percentage cover of all organisms. The ratio was then interpreted using the following quantification, where a score of 1 would indicate a very poor condition, while a score of 4 would indicate an excellent condition. Whereas the mortality ratio was calculated by dividing the percentage cover of dead corals with the combined cover of dead and live corals. The ratio was then evaluated using the following quantification, where a score of 1 would indicate a very poor condition, while a score of 4 would indicate an excellent condition. For the statistical procedures of the study, the SPSS software was utilized in calculating statistical conclusions. One way ANOVA was conducted to identify whether there was a significant difference between the live coral populations present on the sites. Chuki post-hoc test was used to distinguish the dissimilar populations. Regression analysis was performed to identify significant relationships between the cover of live hard corals and the cover of other categories, and then
Presented here are the results of the assessment of the benthic community structure and composition in MATARINAO Bay. The community structure and assemblages of marine benthic community organisms and substrates were investigated in the marine protected areas in MATARINAO Bay. The composition of the benthic community in MATARINAO Bay is shown in Figure 1. In the present study, the abiotic substrates had the highest percentage composition, 32.9% in the study area over the experimental period. The dominant benthic organism was algae with a percentage composition of 27.8%. The hard corals came in third with a percentage composition of 23.9%, indicating their key role in maintaining the marine benthic community and controlling biogeochemical cycling. The hard coral and macroalgal composition showed distinct spatial variations, both within and between zones in the marine protected areas in MATARINAO Bay. For dead corals, the percentage composition was 14.7%. For sponges and other sessile organisms or fauna, the percentage composition was 0.3%, while soft corals had the lowest percentage composition of 0.2% in MATARINAO Bay. The benthic life forms and abiotic substrates that dominated the benthic community in MATARINAO Bay were hard coral, algae assemblages, and sand, as shown in Figure 2. The percentage of hard coral cover varied between the inside and outside zones, ranging from 31.3% to 42%. The highest percentage of hard coral cover was found in the Dio Island outside zone with 42%, followed by Minalongan inside zone with 38.8%, Dio Island inside zone with 37.3%, and Bulawan inside zone with 31.3%. The most dominant benthic life form was observed in San Miguel inside, Minalongan outside, and Bulawan inside with a percentage cover of algal assemblages of 39.1%, 33.3%, and 28.8% respectively. Moreover, the abiotic substrate, sand, had the highest percentage cover of 35.5% in Bulawan inside. A healthy coral reef is generally characterized by its relatively high hard coral cover. The loss of coral dominance in MATARINAO Bay could be an indication of ecosystem stress. Table 1 shows the bioerosion and mortality ratio in MATARINAO Bay, wherein it was inferred that the bioerosion ratio of 0.36 was poor in its coral community, while the mortality ratio of 0.38 was good. The low bioerosion ratio of the benthic community in MATARINAO Bay may indicate that the premature burial of corals was minimized despite the high percentage cover of sediments in the area, which limited the mortality of corals. Based on the monitoring carried out in the marine protected areas in MATARINAO Bay, the observation showed that the percentage of coral cover varied between 5.3% and 39.6%. Dio Island was the only MPA to obtain a score of 3 on the 5-point category scale based on live coral cover by Uchiyako and others, with the highest live coral cover of 39.6%. Bulawan and Banalongan obtained a score of 2 on the 5-point category scale with a live coral cover of 26.9% and 23.6% respectively. Meanwhile, San Miguel obtained the lowest score of 1 on the 5-point category scale with a live coral cover of 5.3%. The overall score of the live coral cover in Matarinaw Bay was 2, with a mean live coral cover of 23.9%. These results concluded that the condition of the coral reef health in Matarinaw Bay was in poor condition. The one-way analysis of variance test was used to determine whether to observe differences in live coral cover within the zones or sectors in the marine protected areas in Matarinaw Bay are statistically significant or not. A significance level of 0.05 was used for the one-way ANOVA test. Presented in Table 3 are the results of the one-way ANOVA test, wherein the significance value calculated was less than 0.05. The result of the ANOVA test implied that there was a significant difference between the sites in Matarinaw Bay with regards to live coral cover. The Tukey post-hoc test was also used to examine the significant difference that was identified by the one-way ANOVA test. A significance level of 0.05 was used for the one-way Tukey post-hoc test. As shown in Table 4, the sites in Group 1, which was comprised of San Miguel inside, Manalongan outside, and Bulawan outside, are not different with each other since its p-value was greater than 0.05. And the same goes for Group 2 and Group 3. In order to assess underlying relationships of the live coral population in Matarinaw Bay for coral monitoring, a regression analysis was performed. The results of the regression analysis showed that the dead corals and the biotic substrates have a significant relationship with the live corals since their p-values were less than 0.05. Pearson correlation test was applied to determine the type of relationship that is present on the variables. The results of the Pearson correlation test indicate that dead corals had a strongly positive relationship with live corals, while abiotic factors had a strongly negative relationship with live corals. The strong positive relationship between live corals and dead corals can indicate that cues for environmental unsuitability are present for the growth of corals, while abiotic substrates prevent corals from reestablishing and even allow algal turfs to come in and compete with corals for space. Some coral species are more sensitive to these stressors, and the increased amount of suspended sand and other sediments may lead to coral degradation if not prevented. In the Pearson correlation test, abiotic components had a strongly negative relationship with live corals, implying that an increased cover of these abiotic components would cause a decrease in the percent cover of live corals. The results of the present study and the analysis of the secondary data of the BENTHIC community of Matarinaw Bay lead us to the following conclusions. First, Matarinaw Bay was mostly covered by non-living substrates such as sand, silt, rubble, and rocks. Second, the coral reef in Matarinaw Bay was identified to be in poor condition due to its low live coral cover. Third, the bioerosion ratio in Matarinaw Bay was indicated to be in poor condition, while the coral mortality ratio was implied to be in good condition. Fourth, there was a significant difference in the live coral cover of each site, wherein it was identified that both San Miguel inside and Manalongan outside had lower live coral cover than Dio Island outside. Lastly, significant relationships were found between live corals and dead corals, as well as with abiotic substrates. Dead corals had a strong positive relationship with live corals, implying the possibility of habitat and suitability for branching corals and the dominance of massive corals. The abiotic substrates had a strong negative relationship with live corals, for it can cause detrimental effects on live corals that can lead to increased mortality.
Conferring to the acquired results from the analysis and interpretation of data, the following recommendations were formulated. Coral restoration efforts need to be directed toward the rehabilitation and nourishment of the coral population in the area. Monitor and study temperature of the MPAs inside and outside to assess the occurrence of coral bleaching in MATARINAO Bay. According to the study of Wooldridge and Doan, the best method for predicting coral bleaching events is through the utilization of sea surface temperature, because it can measure the site's heat stress, acclimatization temperatures, and the type of coral communities occurring in the area. Further examination of the high sand and silt accumulation in the area to determine its cause and minimize the mortality of corals, because it can compete for space or can prematurely bury them. Examination of the long-term spatiotemporal changes in macroalgal cover and benthic hard coral cover in MATARINAO Bay to explore the patterns or shifts in benthic reef degradation in the area. Regular conduct of rapid resource assessment, at least every 1 to 3 years, as advised by the Australian Institute of Marine Science and the IUCN Marine Program, to monitor long-term trends within the benthic community. And lastly, an effective management plan should be administered to ensure the sustainable development of the benthic community in MATARINAO Bay. The findings of this study emphasize the need to formulate a management plan for the benthic community and MATARINAO Bay as a whole. The primary goal of the plan is to support and empower communities and for the relevant assigned groups and stakeholders to manage the coastal resources and areas within MATARINAO Bay. The following are proposed steps that may be taken by the assigned groups or agencies to better manage the MPAs in MATARINAO Bay. First, establish better connections with relevant sectors, especially with local communities as they are mainly affected. Thus, it is important to encourage their participation to collaboratively outline a management model. Second, raise awareness on the importance of protecting the MPAs and marine conservation needs. With more people supporting the protection of MPAs, a common interest will be established and external support and funding may come easier. Third, formulation of alternative livelihood programs for the community. This is essential for conservation, well-being of local people, and to offset possible losses due to the establishment of MPAs. Understanding the community's assets is the first step to diversify strategies for income generation. Fourth, make plans for financial sustainability. Managers may do so by raising funds through user or tourist fees, seeking donations in environmental funds, and retaining the funds for the management of MPAs. Fifth, ensure research, monitoring activities, evaluations, and reviews. Assessing potential drivers of threats and changes in the benthic community condition would be beneficial in making necessary adjustments to the management plans. And lastly, identify areas that need restoration and facilitate possible restoration. Some effects of stressors are reversible, and it is important to identify these and take action with time in consideration. This management plan adheres to the principles of conservation, protection, and management of coastal resources to promote and ensure the sustainable development of the coastal ecosystem in MATARINAO Bay. With these, the current condition of the marine life could be improved without hindering the people that live within and depend upon its resources from yielding benefits, while still conserving its potential to meet the needs of future generations.
Presented here are the references used in this study.